Math 7, Graphing Rotations, Unit 8, Lesson 7. This is page 327 to 328, number 1, 2, 3, and 6. Let's look at 1. It says each grid shows a shape and its rotation image. Identify the angle and direction of rotation and the point of rotation. Okay, so the angle that it rotates and the point. It's got this picture. So there's this shape here, triangle PQR, and it rotates to PQ prime and R. I'm just gonna draw in some circles with the compass just to show that these are a rotation about the origin. That's where it's going to rotate about. So right down here, I've drawn a little rotation, and you'll notice that it goes through, P goes through P prime, and it was by drawing a circle with my pin on the origin. As well, Q and Q prime are also on the same arc, which means it's a rotation about the origin. And if I take this and line it up with R, quickly do an arc, it goes through R and R prime, which means that that center point that it's rotating around, if this was a big circle on each of those, the center point is the origin. So that's the point of rotation. So the origin is a point of rotation, and we're going to say it's going to be about the origin, and it's a rotation. We know it's a rotation because it's just a turning of the shape, right? Now, how many degrees is it? Now, let's look at this. For each of these arcs, if we draw that angle right there, if we connect to the origin and we draw an angle, it's a 90-degree angle right there. If we check this one, if we were to take our ruler and connect each of these points to the origin, and then use our protractor that I'm having trouble picking up, line up one line of it with the center, then our, keep shifting it, then it would line up at 90 degrees, okay? And that would work for all three of them. So it is a 90-degree angle, okay? So it's 90 degrees, but is it a positive rotation or a negative rotation? Remember, if it goes from one and rotates around counterclockwise, let me zoom out again. Counterclockwise is positive, clockwise is negative. It's going from this shape to that shape. So it would be a clockwise rotation, which means it's negative 90-degree rotation about the origin. And we'll find out in a later question that there's actually a couple other answers that it could be, but this is the most simple. I'm just going to put this, if you said 270 degrees about the origin, that would also technically be correct here. But we usually go with whatever the least number is. All right, let's look at B. But first, negative 90 would be one mark, and about the origin would be another mark. So this is out of 2 here. All right, we've got this shape here. It's triangle CDE. It rotated around somehow. And we're going to notice that each of these points is that same distance from the origin as its counterpoint, okay? So D is 1 away, D prime is 1 away, E is 6 away, E prime is 6 away, and C would be 2, 2, 2, 2, which tells you that this is that point. That's where it's rotating about. So it's about origin again. That's the point of rotation. And what's the angle of rotation? Okay, well, it has rotated around so that it's basically on the other side. You notice that these are all in line with the origin. If you drew a line straight through the origin to the other side, you'd get to that counterpoint, which means that it would be a 180-degree rotation. So it's a 180-degree rotation. It's also a negative 180. So, you know, this is negative 180, but it's also 180 going the other way. So either negative or positive 180-degree rotation. I forgot that word, rotation about the origin. So 180 degrees and about origin would be your 2 marks there. Now, there's a couple other ways we could solve these 2 questions, and I'm just going to show them quickly. I'm going to write out what each of these points are and what the other points are, and we'll use those patterns we learned in the lesson. So first, let's take P. That was -1 and 0. Q was 0 and then +3. And R was -6, +5. Then let's look at our primes. Okay. P prime was 0, +1. Q prime was 3 and 0. And R was +5, +6. Notice here, we have our y value from this switching to become our x values, and our x values switches to become the opposite sign for our y values. So these are the same, but these switch sign, and so they switch, which if we remember from our lesson, 90-degree rotations, we flip the x and y values, and then we compare with the quadrants, or it's usually one of them is switching the sign. So let's compare with our quadrants. It went from quadrant 2, which was always a negative to, a negative x and a positive, to this quadrant, which is positive and positive. Okay, so notice we just, for 90 degrees, we switch our x and y values and then just make it so that it follows the quadrant signs. Now, 0 is neither negative nor positive, so you just leave those for it. For question 1b, you'd still come up with the same answer. You'd still declare that it's 90 degrees, and when it's going this way, it would be -90, and it's about the origin. So these rules are for when it's about the origin. Here, we've got 180-degree rotation about the origin. Let's look at our points. C is -2, -2. D is -1, 0. E is -6, 0. Which becomes C prime, D prime, and E prime. C prime simply becomes +2, +2. D prime becomes +1, 0. And E prime becomes +6, 0. If we remember the shorthand for this, for a 180-degree rotation, we simply just flip the signs. That's what we learned. Okay, 180-degree rotations, we're just flipping the signs. So when we rotate around, it goes from being a negative in quadrant 3 to in quadrant 1, it's just positive and positive. If it's flipping around the origin, if it's rotating about the origin, that means that we can follow this shorthand and just take our signs and just change them to positive if they're negative or negative if they're positive. You'll see that it follows through that way. So that's just a different way you could have come up with the answer here. And you know what? This is probably the way I would have done it if I couldn't just look at it and see these right angles. This doesn't work so well when a rotation is maybe less than 90 degrees. Like what if R ended up here, right? You would have a less than 90 degrees, so it wouldn't work so well. This point here, for example, would be about 3.75 and 7. It's not so easy, but when it's an exact 90 degree or an exact 180, it's a lot easier. That was a lot of time for question 1, so let's go a little quicker on question 2, hopefully. Question 2 shows this, and it says, identify the transformation that moves the shape in quadrant 2, which is this one, right? This is quadrant 2, because this is quadrant 1, this is quadrant 3, and this is quadrant 4. 1, 2, 3, 4. Quadrant 2 to each image. So say what it is. Is it a translation? Is it a rotation? Is it a reflection? And explain how you know. So let's do the first one. Shape 1, what is it? Well, if we look at this, each of its points, each of these corner points, in fact, any point around here, the equivalent point, would end up rotating around and just switching signs, right? Or we could measure from it, it goes 2 over, 1 up, which is 3, goes 2 up, 1 over, which is 3. Or what about this point here? It's 4 up, 1 over, which is 5 in total. This is its similar point, right? It would be 4 over and 1 up, which is 5. So this simply is just a rotation, right? This would be a rotation about the origin. And how much is it? Well, it'd go from here to there, which is in clockwise. So it's a 90-degree clockwise, which would be negative 90 degrees. So negative 90 rotation about the origin. So the answer here would be rotation. That's the key word I'm looking for in this question. I also forgot to point this out. Oh no, I did in first question, sorry. Next shape, shape 2, which is in quadrant 3, ironically. It's not a quadrant 2 because that's a shape. How are these two related? Well, one could flip over to the other side, right? It could flip over. If each of these points perpendicularly to the line that it is flipping over have the same distance, which they do, all these points have the same distance. For example, this point and this point, they have 1, 2, 3, 4. This is 1, 2, 3, 4. This would be a reflection over x-axis. You know what? I'm giving more marks for these questions. I want to see this about the origin, and I want to see negative 90. That's going to become 3 marks. I want to see negative 90 rotation about the origin, or you could have said 90 degrees clockwise. That's acceptable instead of the negative 90. I almost wrote clockwise. Funny. Reflection and x-axis, that's the important part there. So this part's out of 2. And then the third shape. Compare these. Well, it's just shifted down, right? It's just moved. So it is a translation. And how far did it move? Well, it moved over 1, 2, 3, 4, 5. 5 right. And 1, 2, 3, 4, 5 down. Okay. 5 down's a mark, 5 right's a mark, and translation is a mark out of 3. So question 1 was out of 4 in total, and question 2 was out of 8 in total. Okay. Let's do question 3. All right, question 3 says copy triangle DEF, which it's in your book on the right side there. So I've copied it in here. So I'm going to get 1 mark for just copying. Okay. Write the coordinates of each vertex. So vertex, that's these little corners, okay? We're going to write those. So part A here is copy and write this. So we have D, for example, is negative 2, negative 1. Okay, E is negative 5, negative 3. And F is, not equals, F is negative 1, negative 5. Okay, so 1 mark for each of these. Then it says after each rotation, so each time we do something in the next questions, we need to write the coordinates of the image of each vertex and describe the positional change of the vertices of the triangle. So we're going to describe how it changed. Okay, so let's have a look at this. B says rotate DEF negative 90 degrees about the origin to its image triangle D prime, E prime, F prime. So negative 90 degrees. So positive is when it goes from quadrant 1 to 2 to 3 to 4. So negative would be 3 to 2 to 1, 3 to 2. So we're moving to 2, 90 degrees is just to the next one over. So that means that all of these, let's write B in here, all of these become prime ones, right? They all become a prime. Okay. And what's our rule for 90 degrees? We flip these and then make it line up with what it is. This quadrant is negative and negative. This one, remember, x's are all negative numbers you see here, so it's negative, and then the y's are positive. Okay, so it's going to become a negative number for sure, and then it's for sure going to become a positive number, or 0 if it's right on these lines, but it's going to become a positive number. And then with a 90 degree, we just flip these. So the 1 becomes a 2 and a 2 becomes a 1. Just flip them. And these are just going to stay positive. So there's our points. Let's graph these. D prime is negative 1, 2, negative 1, 2. That's D prime. E is negative 3, 5, negative 3, all the way up to 5 is E prime. F prime is negative 5, 1, negative 5, 1. That's F prime. And connect it using your ruler. Okay. And you could check it by taking a compass and, drawing your circle around, making sure they're the same amount, or you could just count left, right, or up and down how many squares, and it needs to be the same if it's the same letter. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we could do that for all of them, and it should be the same. As well, when it's a 90-degree turn, your distance from each point to the x-axis will become the distance to it, the y-axis. So here, D is 1 away from the x-axis, whereas in this next one, D is 1 away from the y-axis. D is 2 away from the y-axis, so D prime becomes 2 away from the x-axis. So the axes just switch. All right. So we rotated it. We wrote the coordinates. So drawing it, okay, and labeling it is going to be 1 mark. And then 1 for each of these coordinate pairings. Now, let's just think about something here. Question C says to rotate DEF positive 270 degrees about the origin to form its image D double prime, E double prime, F double prime. So we're doing a plus 270 degree rotation, which means positive is going this way, and we're going to move this around 90 degrees, 180 degrees, 270 degrees. Interesting. Think about it. All the way around a circle is how many degrees? It's 360 degrees. 360 degrees, get rid of this 270 from it. 270, it becomes 90 degrees. So a 270 degree rotation is the same as a negative 90 degree rotation. The opposite, right? So a negative 270 would be the same thing as a positive 90. So a negative 90 is the same thing as a positive 270 because it's just going the other way. So to draw this, D double prime is actually the same thing as D prime. E double prime is the same thing as D prime. And F double prime is also the same thing as F prime. So we could just label these twice and we have the same thing. Okay, so 1 mark for each of those and 1 mark for labeling or drawing it. Make sure you ask me questions in the comments if you're confused about this whole thing where the 270 is the same as the negative 90. Another way you could do this, you know, take the origin, line it up with your point here, right? And go 180 degrees around. Connect that dot to the origin, right? So there's 180 degrees, and then do 90 degrees more than that. Put it back on origin, do 90 degrees more right here. Connect that dot. So 180 plus 90 is 270 in total. So that 270 degrees around would bring us to this point. Why? Because it needs to be the same distance from this point, right? So if we do that, we get our line that is 270 degrees. It's moved 270 degrees around. And then we take our compass, line it up with that middle point, and just do a circle. Where does it go through on that other... Oh, that's a little too big. Sorry, guys. Where does it go through over here? Well, it goes through this point right here, which is 1 and 2 dimensions away, 1 and 2 away, which means that this must be that point that is the D double prime. That's another way to do it. Question D says, what do you notice about the images in part B and C? Well, both images have the same coordinates. Both images have the same coordinates. So do you think you get a similar result with any shape you rotate 90 degrees, negative 90 degrees and 270? Yeah, no matter which point it is, no matter what shape it is, negative 90 and 270 positive will be the same. In fact, any two numbers that add up to 360, any two numbers that add to 360, if you make one of them a negative rotation and the other one positive, they will always end up at the same place around. I'll make that out of 1 mark just for saying they have the same coordinates. So, it's going to be 2 marks because, and yes, negative 90 and 270 will produce the same shape no matter what the shape is. So yes, and then both have the same coordinates. Same coordinates is 1 mark, yes is 1 mark. So 2 plus 4 is 6, plus 4 is 10, plus 4 is 14 for question 3. Now let's do 6. All right, question 6 has a bunch of points that we need to plot on a coordinate grid for part A, and we're going to join the points in order from A, B, C, D, E, F, and then F back to A to make a 6-sided shape. So A is 6, 0. I'm just going to write these in here on the side. If you want to write them actually on right beside your letter, if you can write small enough, go for that. But I'll write it on the side just to keep it organized. B is 6, 2. C is 5, 3. D is 4, 2. E is 2, 2. And F is 2, 0. I also noticed that it's moving by, 6 units, so I want to make sure that whatever my biggest unit was plus 6 would be the same thing in the next question. So I drew my grid going up by 2 and down by 2, so my scale was 2 instead of 1, just so it could fit on my page, but I'd still have enough room. So 6, A is 6 and 0, so A goes right here. B is 6 and 2, so 6 and 2 is B. C is 5 and 3, so 5 is halfway here and 3 is halfway there, so that's C. 4 and 2 is D, 4 and 2 is D. Sorry, I forgot to label C. E is 2 and 2, 2 and 2 is E. And F is 2 and 0, so 2 and stay is 0. And then connect the dots. I'm going to zoom in on this. There we go. I missed the pause button. Oops. So let's connect A to B, B to C, C to D, D to E, E to F, and F back to A we don't need to redraw because it's right on the axes, so there's a line there anyways, and we'll just assume that we know that it's there. Okay, so that's question 1, and so 6A, I mean, A. And we joined it, we put them on the grid, so for each of these in the right spot would be 1 mark, so out of 6. Okay, B, that's A. B, let's just do it over here. Okay, zoom out a bit. B says, translate, so that just means move it, shift it, the polygon 6 units left and 2 units up. Write the coordinates of each vertex on the image polygon. Okay, so it's going to be 6 up and 3 right. You know what? I'm going to write B to the side here. If you think about it, 6 up just means plus 6 to your, 6 left is just 6 less, left is less for your x coordinate, and 2 units up is plus 2 for your y. So we're going to take 6 away from all of our x coordinates. 6 subtract 6 is 0. 6 subtract 6 is 0. 5 subtract 6 is -1. 4 subtract 6 is -2. 2 subtract 6 is -4. And 2 subtract 6 again is -4. And then we're moving up in the y coordinate by 2. We're moving up by 2, which means that this will become 2 more, this will become 2 more, this will become 2 more, 2 more, 2 more, and 2 more. So here are our coordinates. So that's out of 6 for our coordinates. And we're also getting a mark, I forgot to say this, mark for drawing it on here. Each of these drawn on here was a mark right there. And then here, getting our coordinates, that's 6 marks, and putting them on would be 6 more for putting them in the right spot. So let's do this. We're going to move these each 6 left and then up. So F is going to move 6 left, 1, 2, 3, sorry, what did I do wrong? This scale is by 2, right? 2, 4, 6 is right here is F prime. No, it's not. Because why? We need to move y up 2. We need to do 6 over and then 2 up. So 2, 4, 6, 2. That's F prime. What about A? 2, 4, 6, 2 up. That's A prime. And then we could probably just draw our shape pretty easily just by copying it over, by just making sure it looks exactly like this, right? And then just make sure we keep these as the right labels. And then we can connect them, use a ruler, or else it looks like mine with squiggly lines a little bit. So we drew it on here, so that's going to be 6 marks drawing it on there. You know what, maybe I'll put that 6 over to that side, and then it's 6 marks for labeling the points. B says to rotate the image polygon A prime, B prime, C prime, D prime, E prime, F by 90 degrees counterclockwise about the origin. And then we are going to write those ones, and we're labeling this with the double primes, okay? So we're doing 90-degree rotation counterclockwise. Okay, counterclockwise. So for part C, we're going to rotate the image polygon. So that's this one. It's not this one. We're rotating this one 90 degrees counterclockwise, which means a rotation like this. It's going to move from quadrant 2, which has negative, positive as its x and its y's. So now it's negative, negative, it's moving to 3, right? It's moving 90 degrees. And remember our rule, we take our coordinates, we switch them, and then we make them both negative in quadrant 3. So it's going to become -2, 0. It's going to become -4, 0. It's going to become -5 and keep that -1. It's going to become -2, 4, -2. It's going to become negative, I guess I'll need to move up here so you can see. It's going to become -4, -4. And it's going to become -2, -4. Okay, now let's draw these points on this shape. -2, 0 is going to become A double prime. -4, 0 is B double prime. -5, -1, -5, -1 is C double prime. F double prime is -4, -2, -4, -2. Should we zoom in a bit? Oops, that's out. And finally, E is -4, -4, so -4, -4 is E. And F is -2, -4. F double prime. E double prime, there. All right, and then we just connect the dots. Notice it's the same size shape. They're congruent. So you're going to get 6 marks for writing the correct coordinates and 6 marks for putting them in the right spot on the grid. And then D, it says, how does polygon A double prime, etc., compare with polygon A, B, C, D, E? So how does this one compare with this one? It's interesting looking at this. How does it compare? Well, they are congruent shapes, right? They're still the same size, but they're rotated. Now, they wouldn't actually be rotated about the origin. And how do I know this? Well, A double prime is 2 away from the origin, whereas 2 away is A double prime, and this is 6 away. A regular is 6 away. So there's probably some other point down here that it's rotated about, and I would suggest it's actually this point here. It's actually rotated about 2 and -4. Why did I come up with that one? Well, all of these points are the same distance as their counterpart from this one. So that's how I figure that out. A is 2, 2, 4, 2, 4. A prime is 2, 4, 2, 4. F is 2, 4. F double prime is 2, 4. E is 2, 4, 6. E double prime is 2, 4, 6. E is 2, 4, 6. All of these points are the same distance away from this point. That's how I came up with this. However, this one, you're only getting the mark for just saying congruent, so it's just out of 1 mark, but you could have been more specific there. So looking at this, we've got 6, 12, 18, 24, 30, 31 marks for question 6. So 31, 14 is 45, plus 12 is 57 marks. It's out of